Welcome back to Chapter 3. This is Ms. Thusen, and we will be going over biogeochemical cycles in this video. Biogeochemical cycles are very, very important, and they will be something that we will talk about throughout the course. They are a very big foundation because they relate to so many other things and are impacted by so many of the other things we are going to learn this year. So a biogeochemical cycle is just the movement of a nutrient or a compound molecule through our ecosystem and into the geologic and atmospheric locations on our planet. So into the soil and the atmosphere and through living matter. So the first one we're going to talk about, which is really kind of not a biogeochemical cycle, but we throw it in here, is the water cycle. And this is or hydrologic cycle is the more appropriate name, which is just the movement of water, H2O, through our biosphere. The steps that you need to be familiar with and know what happens are evaporation, transpiration, condensation, precipitation, percolation, runoff, and infiltration. And I'll go over those in just 1 minute in the next slide, which is a picture. The driving force behind the water cycle, of course, is the sun, and then stores. Stores are where the vast majority of that compound or molecule is at any given point. So the number one store for the water cycle is the ocean. 97% of the water on Earth is in the ocean. So that would be the major store. Glaciers and ice being the second one, which is about 2%, and then our surface water and groundwater, which is much less than 1%, but is also a smaller store. Okay, so looking at the diagram here, you can see we have evaporation, transpiration, and all the goodies. Let's see here. So evaporation is when water goes from being liquid to being a gas. Transpiration, same thing, liquid to gas. By the way, transpiration and evaporation do not make clouds. They do not. They make water vapor. That humid air after our rains, that is water vapor. Condensation makes clouds. It must have dust to do that. And that can make their clouds or make condensation, which is when water turns back to a liquid, from gas back to a liquid. If there's enough liquid, we get precipitation. Precipitation is rain, sleet, snow, hail, any form of water coming from the atmosphere. If water gets to the ground, then it can either run off, just run down and into one of our local waterways, into our lake or river, or it can infiltrate. Infiltrate means it goes into the ground a little ways and is used by the plants and stuff. If it actually gets all the way down to our groundwater and restores our groundwater down here, that is actually percolation. Okay, so infiltration is just a little bit. If it gets all the way down here, then it's called percolation. Okay, so you need to be familiar with those. The other big thing you need to be familiar with when we talk about our biogeochemical cycles is how humans are impacting these. And this is the stuff that is going to come up throughout this course, and you have to be familiar with it. What are we doing that is impacting these cycles? So humans right now, the major impacts we have are that we are depleting our water sources. We are using a ton of water for irrigation, for agriculture, and other uses, and our water system in our groundwater and aquifers does not get replaced very often. So that's a big deal. Clearing vegetation and deforestation are two biggies as well, or one biggie. They reduce transpiration, which can actually reduce rainfall. So the rainforest occurs because it produces the rain. So they're linked. So if you remove one, you're going to impact the other. So buildings and paving surfaces. This blocks percolation and blocks the recharge of our groundwater, which is a very big deal. And then surface water diversion. These are things like aqueducts and canal systems and things where we are moving water from one area to another. This will be a big discussion we will get into when we actually talk about water later on in the year, because water diversion is a very big deal. A lot of times water is not where we need it to be, so for the human population, so we move it. So that will be a big one. Okay, so moving on to the carbon cycle. Carbon cycle is a very big deal because of global warming. but it is also basically the big one in some ways because we are carbon-based critters. So the steps in the carbon cycle are photosynthesis and respiration. Those are basically the driving forces of the carbon cycle. Plants pull CO2 out of the atmosphere for photosynthesis, and then it moves through the food web through basically assimilation from one organism to another, and then of course respiration releases CO2. Exchange with the ocean, so CO2 moves from our atmosphere and into the ocean. Sedimentation and burial, extraction, combustion. Oops, I have exchange on there twice. And also fossilization is another step in the carbon cycle that's not listed there. Extraction of fossil fuels is a very big deal. Maybe that's supposed to be extraction. Because we burn fossil fuels, which is releasing a lot of CO2 into our atmosphere. We often refer to that as fossil carbon, or because it's basically very old carbon, and is probably not supposed to have seen the light of day again. Our fossil fuels are what we consider a sink. That is a store that is not supposed to be ever in the cycle again. It's basically a chunk of carbon that was removed from the carbon cycle and stored away for permanent, so we refer to it as a sink. The stores for carbon are biomass. We are carbon-based critters. And then your rock and soil. We have lots of carbon in the ground. That's referred to as our modern carbon. That's the carbon that should be cycling. Combustion, decomposition, and respiration, of course, release CO2 and water and energy back to the atmosphere and stuff. So those are going to be your releases of CO2. Photosynthesis is your only removal of CO2 from the atmosphere. Okay. So very complicated carbon cycle from your book, but it shows you that things. I want you to note the exchange here with the ocean. Basically here you have your food web and stuff just like you do up here in the ocean. So a lot of this occurs. There's a lot of sedimentation in the ocean. A lot of carbon ends up in the sediment and gets buried. By the way, your fossil fuels are from plants. They are not dinosaurs. Dinosaurs didn't make your fossil fuels. The plants made your fossil fuels. So your peat makes your coal, and your plant, your algae and stuff from the ocean makes actually your oil. Okay. Another simplified carbon thing kind of showing combustion and cellular respiration are going to basically release CO2 back to our atmosphere. The only thing is you can see, if you see here, this is the atmosphere. The only thing removing carbon is photosynthesis. So if we decrease photosynthesis, we're decreasing the amount of carbon. And if we increase the other things, respiration, combustion, and like forest fires, anything like that, we are increasing the amount of CO2 in our atmosphere, which is a huge concern. Okay, so down to the human impacts. Post-industrial revolution is when we're really having a lot of problems. There's lots of deforestation. It not only decreases the amount of CO2 uptake through photosynthesis, often we also burn those forests or we let them decompose, and that's going to release CO2 to the atmosphere as well. Combustion of fossil fuels, of course, that's considered a carbon sink, and so you're adding all this fossil carbon to the modern carbon cycle that wasn't supposed to be there. So just the volume of carbon in our carbon cycle has changed, and so it has to store somewhere. So it's probably going to be in either the atmosphere or one of the stores. But the fact is, biomass is not increasing on our planet. If anything, it's decreasing because we're taking the forests away. So it's ultimately increasing in the atmosphere. And CO2 is a greenhouse gas, and you'll understand what that means later in the course. But ultimately, that means that we are increasing the amount of energy in the form of heat that is trapped along our planet. And that's going to have consequences. Unfortunately, to some degree, we're going to have to wait and see what those consequences are, which is kind of scary, or can be. Who knows? Okay. let's see if I can get the nitrogen cycle in right here. Nitrogen cycle. You have got to know this cycle. I cannot stress enough that you have to know this cycle. It is a very important cycle. Nitrogen is the #1 limiting factor for the growth of plants on land. It's #2 in the ocean or in aquatic environments. So it is often the limiting factor. So if you have planted a plant and it's not doing well, or you planted your garden and it's not doing well, guess what? You probably need nitrogen. Okay? You have got to know the steps in this, and I will talk to you through these, and I will give you a mnemonic, which is fix, NAD, and ANPAN, to help you remember them. But you have got to know the nitrogen cycle. Okay, so the steps in the nitrogen cycle. The first one is nitrogen fixation. Nitrogen is stored in the atmosphere. Our atmosphere is 78% nitrogen, and it's got to come, that nitrogen in the atmosphere is not usable by us or by plants. So it's got to be fixed. And there's 2 ways it's fixed, either by bacteria in the soil, nitrogen fixing bacteria, or potentially by lightning. Lightning will also fix nitrogen. So biotically, through bacteria, you're going to have N2 gas. Is it changed to ammonia? And then ammonia is converted to ammonium. And ammonium is usable by plants, but it is not their favorite method. Abiotic, which is humans, basically we create fertilizers. More nitrogen is fixed by us for fertilizers than nature fixes anymore. We use so much fertilizer for our agricultural purposes. So in that case, we go from nitrogen gas all the way to nitrate, which is the favorite nitrogen source for plants. That's what they prefer. But in nature, nitrogen is fixed by nitrogen fixing bacteria, and then it goes to the next step, which is nitrification. Nitrifying bacteria convert the ammonium into nitrate, and the nitrate into nitrite into nitrate. Nitrate, again, being the most preferred form of nitrogen for plants. But if nitrate isn't there, they can use nitrate, and they can use ammonium as well. So, yeah. Okay. From there, now it can be assimilated into plants. Plants are going to take up either the ammonium or the nitrate, and they are going to combine it into proteins in their body, and then we are going to consume them. We consume the plants or our proteins, our meats, and we assimilate that nitrogen in the form of proteins. So it's in the amino acids and the nucleic acids. So we get our nitrogen from what we eat. Plants get it from nitrogen-fixing bacteria, and the bacteria in the ground for the most part. The next step is ammonification. This occurs through decomposition. So your protein, your biological nitrogen, your proteins are converted by bacteria and fungus back into ammonium. And then at that point, that ammonium can either go back through nitrification and become nitrate again for plants to be used, or in the case if there is anaerobic conditions like waterlogged soil, that ammonium can go through nitrification by denitrifying bacteria. Again, when there's no oxygen present, the ammonium is converted to nitrous oxide, and then the nitrous oxide is converted to nitrogen gas and released to the atmosphere. So that is another thing that can go on. So fixed NAD and ANPAN is kind of the little cheat for this. And I will have to finish this on the next video. So we'll do the little cheat on the next video. So that will be the end of video 2. Video 3 will be short, thank goodness. I will see you in video 3.